Now we're going to look at how we actually utilize the double angle formulas. So I have them copied here at the top. We have the double angle formula for sine. We have three different versions for the double angle formula for cosine, and then another one for tangent as well. So looking at these three expressions down here, you can hopefully see that some of these mirror what we see up here. So 2 times the tangent of 11 divided by 1 minus tangent squared of 11. This very closely looks like this expression right here, where x in this case is equal to 11. So I can see that this is asking us for the tangent of 2 times 11, or in other words, the tangent of 22 degrees. Now, this isn't something that I would know off the top of my head from the unit circle or anything like that. 22 degrees is not an angle that we commonly work with. So still, if I wanted to actually figure out what this is, I would have to use my calculator and I would have to plug it in while it's in degree mode. So if I would hit the tangent of 22, we would get something like 0.404. So I could figure out what this is approximately, 0.404. But really, this is what I'm hoping that you'll see. This is really what we're evaluating here. 2 times the cosine squared of 38 minus 1. I can see that this is very similar to this equation right here, which is a double angle formula for cosine. In this case, the x is 38. So this is the cosine of 2 times 38. And 2 times 38 is 76. So this is really the cosine of 76 degrees. And again, this isn't something that I would know off the top of my head. So this would be as far as you could get without a calculator. And then finally, the last one, 2 times the sine of 5 times the cosine of 5, looks very similar to this expression right here, where x equals 5. And this is the sine double angle formula. So this would be the sine of 2 times 5, or the sine of 10 degrees. And if you wanted to actually evaluate that, you would need to use your calculator. But I'm really just trying to show you here how these are related to each other. So let's actually use this information to do some calculations here. So if we say that the cosine of x equals, and actually I think this is different than the one on your paper. Let me adjust this so that it's the same as the one on your paper. On your paper, we have that the cosine of x equals a positive 2/3, and that x is in quadrant 1. So this is going to make it a little bit easier. We'll go ahead and do it this way. So I apologize if you started this problem with the other version. So the cosine of x equals 2/3 and x is in quadrant 1. Again, quadrant 1 makes it a lot easier because you're plugging in your formulas the sine of x, the cosine of x. Same thing here, the cosine of x being squared, the sine of x getting squared, the tangent of x. So when x is in quadrant 1, it just makes it a lot easier because everything that you're plugging in here is going to end up being positive. There are situations, so like here, if I had said this was in quadrant 2, well, in quadrant 2 over here, we know that your cosine is negative, which means what you were plugging in here would be negative, or in here, or in here. The tangent would also be negative, so these would be negative when you plug them in. So making it positive just makes it a little bit easier for our first example. So if the cosine of x equals 2/3 and x is in quadrant 1, we want to figure out what is the cosine of 2x. Well, remember, I said that there's three different versions of this equation that can be helpful to us. We are given the cosine of x only. So if you notice, this third equation only uses the cosine of x. You're not required to also have the sine of x. So this equation right here is probably going to be the easiest to utilize. So this is 2 times the cosine squared of x minus 1, which means we're going to use 2. The cosine of x is 2/3, so cosine squared is 2/3 squared minus 1. And then it's just about simplifying the expression. So 2 times, well, 2/3 squared is 2/3 times 2/3, or 2 squared, which is 4, over 3 squared, which is 9, and then minus 1. We want to multiply first, so 2 times 4, this is going to be 8/9 minus 1, or minus 9/9. So we're going to get negative 1/9 for the cosine of 2x. And I want you to think about why this would make sense. I know it might seem strange to get a negative answer there, but if you're looking at this on the unit circle and you're thinking, okay, x is in quadrant 1, so let's say that this angle right here is x. Well, if you double that, it would make sense then that this angle doubled could land you over here. So this angle right here is double x. So its cosine, since it's over here in the second quadrant, would be negative. So that makes sense here. Now, when we're trying to find these other ones, like the sine of 2x, the formula for that is 2 times the sine of x times the cosine of x. Whoops, 2 times the sine of x times the cosine of x. Well, again, I was only given the cosine of x. I wasn't given the sine of x. So this is a situation where, like before, we would want to draw a triangle. And so we have our right triangle here. If this is angle x, we know that the cosine was 2/3, so that's adjacent over hypotenuse. So we need to solve for this third side, the second leg, and we could do that by saying 2 squared plus b squared, or whatever you want to call it, equals 3 squared. So in this case, b squared would equal 9 minus 4, which would be 5. So that side is going to be the square root of 5. So now we're able to see that the sine of x is root 5 over 3, which means we have all the information we need for this formula. So this is going to equal 2 times the sine of x, we said is root 5 over 3, times the cosine of x, we already knew was 2/3. So if we were to multiply across, 2 times 2 is 4 root 5 over 3 times 3 is 9. The square root of 5 does not simplify any further, and 4/9 does not simplify any further as well, which means this would be our final answer. And again, if 2x happens to land right here in the second quadrant, it would make sense that our sine would be positive of that angle. Last one, we can actually do this in a variety of ways. The tangent of 2x, we can utilize this formula. Another way, though, is if you have the sine of 2x and the cosine of 2x, you can just go ahead and do the sine of 2x divided by the cosine of 2x. So I'll show you both ways. If we want to use the formula, first, this is 2 times the tangent of x over 1 minus tangent squared of x. So in this case, 2 times, well, the tangent of x, again, if I utilize this picture, this right triangle, the tangent is root 5 over 2. So this is going to be 2 times root 5 over 2 in the numerator over 1 minus, and then again, the tangent is root 5 over 2, but we're going to square that. So root 5 over 2 squared. So 2 times root 5 over 2 is going to simplify to just be root 5 because you have a factor of 2 in the numerator and denominator, which would simplify to 1, over, well, let's first square root 5 over 2. Square root of 5 times square root of 5 is 5, and 2 times 2 is 4, so it's going to be 5/4. So we really have 1 minus 5/4, or in other words, 4/4 minus 5/4. So 4/4 minus 5/4 is negative 1/4. So the square root of 5 divided by a fraction of negative 1/4, negative 1/4 is the same as the square root of 5 times the reciprocal of negative 4 over 1. So this turns out to be negative 4 root 5. Real quick, I'll show you it's the same exact thing if you were to take the sine of 2x divided by the tangent, or I'm sorry, divided by the cosine of 2x, because that's what tangent of 2x equals, right? Tangent of 2x is the sine of that angle divided by the cosine of that angle. And since we found both of those, we can utilize that. So the sine of 2x was 4 root 5 over 9. And then dividing by the cosine of 2x is negative 1/9. That's the same thing as multiplying by its reciprocal, which is negative 9 over 1. So the 9s are going to simplify. You'll be left with a negative 4 root 5. So you get the same answer either way. This is obviously only easy if you have already discovered what the sine of 2x and the cosine of 2x are. But if you don't have those, then you're going to need to use that formula.